what are the main key developments that you were able to report today, and where are we at with SESAR?
Okay. So air traffic control is largely depending on very old technologies, which are dating for some of them from the 1950s, and SESAR aims at replacing those technologies with state-of-the-art, let's say, networking and computer science technologies. Now, we are making a lot of progress in setting up this program, in running this program. Today we have 2,000 people working in the program all across Europe, and including some countries such as the United States, India, and so on and so forth. We have started to deliver some significant results, such as, for instance, enabling aircraft to follow GPS-based trajectories into aircraft, so that they do not have to follow extremely rigid routes which are based on ground navigation aids. So we enable to have more flexible trajectories, much more precise, with less noise, with less emissions, and typically we are trying to run some what we call gate-to-gate flights, which are starting right from the gate at the airport and finishing at the other gate of the airport with green procedures in all of the different phases of the flight. So we have done that for Paris to Miami flights, for instance, and it shows extremely significant gains in terms of fuel consumption and therefore emissions. And I think it's a good sign for the future. Typically with the current technology, so without making any new investment into new technologies, we were able to save some 2 to 3% in terms of CO2 emissions on a flight between Paris and Miami. This is quite good. Most of the work that we had to perform was to coordinate all the new operational procedures, making sure that all the actors were working together with a common goal. So we worked with the Irish and with NATS, in fact, to optimize the trajectories in the airspace which is over the Atlantic. So we did not deal with the Dublin area at all, but we dealt with the oceanic airspace. Today, if you have a flight which is crossing the Atlantic, once it is set on a particular route, track, we call it an oceanic track, it cannot change. Whereas it can be just behind an aircraft which is slower than this aircraft, or through the trajectory, the winds can change, and therefore it may be more interesting to change the route. Today we cannot do that. So we worked a lot with our colleagues in the UK and in Ireland to kind of break that rigidity and make the routes over the Atlantic more flexible, so that if the winds change, if there is anything which changes on a flight, then the aircraft is able to take into account those changes and have the most optimal route. AIR is an initiative that we launched together with the US, which aimed at working on operational procedures in order to be greener. So basically we did not require in air to have any kind of investment in new technologies, new engines or things like that, but we were saying take the existing aircraft and let's work out a greener operation for that type of aircraft. And basically what we did was that we forced airlines, air traffic control services and airports to work together and propose to us how they can work together and have greener operations. Something very simple. We funded under AIR a project in Paris Charles de Gaulle, in which the goal was to have no stops for the aircraft on the ground. You know, whenever an aircraft starts to move, if it stops, it requires a lot of engine power to make it move again. So basically, if you can ensure that, you know, even at a slower speed, but you do not stop the aircraft whilst it is taxiing on the ground, then you have a better performance in terms of environment. So this is typically something that we did with Aéroports de Paris, with Air France, and with the air traffic control, to work on new ways of operating aircraft on the ground. We did the same for oceanic airspace over the Atlantic. We did the same, and therefore in the Irish airspace. We did the same in approach, in climb. So we funded under AIR 6 projects last year. We are funding 18 projects this year, which aim at demonstrating that without any major investment in new technologies, just by agreeing on common procedures, common operations, then we can make significant gains in terms of environmental sustainability. We are working in quite a conservative industry, and bringing change is not easy. Bringing change to all actors at the same time is even more difficult. So in SESAR, the way we deal with it is to build a public-private partnership. We have today 80 companies which are working with us. And basically what we try to do is to force them to work together, force them to share their best practices, force them to agree on, you do that and I don't do it, but you have to inform me. And it took us quite a long time. It took us 2 years to negotiate that. Especially when you talk about competitors that have to agree on ways to work together. But we are there, and we are building all this working together culture. So far it shows quite impressive results, but we are not yet at the goal, and we still need to continue to work together. This is what SESAR is about. It's getting rid of the ground-based infrastructure and making sure that the aircraft can fly the most optimal profile in their path.